Okay, as you continue to go through trig identities, it is once again, you have to experience them and you have to try to mud yourself through them. It is nothing that you just cannot wave a magic wand over and say it happens. If we take a look at, I'll take a look at a few problems here today. Once again, we'll go through them. Hopefully this will help you in regards to working through some of the problems. If we take a look at, number 12. We have secant to the fourth of t minus tangent to the fourth t, and we want this to equal 1 plus 2 tangent squared t. Okay, we talk about dealing with working through problems. If you have square terms or fourth terms, you should be steering yourself towards the sine squared plus cosine squared is equal to 1, or the secant squared is equal to 1 plus tangent squared. You should be gearing yourself towards those things. If you don't have degrees to the exponents, that's where you're going to start looking at changing things to 1 over sine, or changing things in terms of sines and cosines. Okay? But if we take a look at this one, on the left-hand side, you know, where do you start at? You can start with either side and you want to try to work to the other. Like I tell people in the past, what side do you start with? You look to see what has like bigger stuff, more stuff to it, that's more complicated, and try to work to the other side. Right? Why you look for stuff that is bigger and you have more stuff there is it is easier to destruct things than it is to construct things. Okay? With the right tools, we can destroy a house in a matter of hours. Okay? With the right tools, you can just take a house out and haul away. You can do that within hours. Okay? But look, to build that house so it's livable, not going to be able to do that in just hours. Okay? It takes a little bit more time. So if we look at the left-hand side, I try to simplify these and break these down into algebraic terms and take away the trigonometric ideas. If you had x to the fourth minus y to the fourth, and I asked you to factor that as the difference of perfect squares. Well, what you're used to back in the algebra world is if you had x squared plus y squared, or x squared minus y squared, and you look to factor that, x squared minus y squared would factor to what? Random, what would x squared minus y squared factor to? Those squares, difference of perfect squares.
X squared, wait, x.
No, just x squared minus y squared. If I look to factor that, I need my first two terms multiplied together to get x squared. What would that be? X and x. My last two terms have to go to get y squared. Y and y. And what's our sign going to be? One's minus, and then the other one is plus. Difference of perfect squares. So I'd have x squared, I have a minus xy, I have a plus xy. They go bye-bye, and then we have a minus y squared. That's your difference of perfect squares. I want to use that same idea down here to x to the fourth minus y to the fourth. So if I looked at that factor that, Victoria, what would that factor to?
X squared minus y squared, x squared plus y squared.
Okay, so now I'm going to take this down here and throw it into the trigonometric world. Rather than x's and y's, we have secants and tangents. So it will factor the same way. It will factor the exact same way. You just basically replace the x with secant, and you replace the y with tangent. And you rewrite. And once again, this is a technique also that may be helpful for you as when it gets a little bit more complicated, just throw in x's and y's and do it in that and then replace. Once again, we have x to the fourth, we have y minus y to the fourth, the x squared y squared cancels the x squared with the other x squared y squared. It's a difference of perfect squares. It's your algebraic factoring. So we have secant squared minus tangent squared, and secant, let's throw a t in there, then secant squared t plus tangent squared t. Okay, now we have secant squareds and tangent squareds. If you look at what we have, you scan down through what we have done already in regards to things that you can use for replacements. You can steer yourself towards the secant squareds and the tangent squareds. Why? Because that's what we have there. Well, what you have on the one is secant squared is equal to tangent squared plus 1. Okay, that should be one that you have there. Okay, as you scan down, secant squared equals tangent squared plus 1 or 1 plus tangent squared. Does not matter. If I would subtract tangent squared from both sides, what you're left with is secant squared x minus tangent squared x is equal to 1. So you have secant squared minus tangent squared is equal to 1. Well, if we take a look at our factorings, we have a secant squared minus tangent squared. So using our substitution principle, what substitution is, once again, you're replacing one thing with its equal. What is this thing equal? Well, secant squared minus tangent squared, we just showed over here, is equal to a value of 1. So that's 1. We also take a look at where we're trying to still get to. Keep an eyeball at the end. What are we looking at? Well, what we're looking at here is we're trying to get all this to things in terms of tangent. Okay, so I have no secants here, but I have tangents here. Well, what I'm still left with here is secant squared plus tangent squared. So you look at, what do I have there? What do I need to get rid of, and what do I need to turn it into? Well, what we want to get rid of is the secant. Well, the secant is a secant squared. We want to turn that into the tangent world. Well, what we stated over here at the beginning, and we worked at from the beginning, is secant squared is equal to tangent squared plus 1. So this right here, we can replace or substitute in as tangent squared t plus 1 plus another tangent squared t. If we had y squared plus 1 plus another y squared, and I ask you to combine alike terms, y squared plus 1 plus another y squared, and I ask you to combine alike terms. Zach, how can we rewrite y squared plus 1 plus y squared if we combine like terms?
Y to the fourth plus 1.
So if I have y squared plus another y squared, that gives me y to the fourth.
Oh, 2y squared.
2y squared. So this gives me 1 plus 2y squared. Well, if I have tangent squared plus 1 plus another tangent squared, that will give me 1 plus 2 tangent squared. We is done. What's your question, Zach?
So up there you have tangent 2 plus, or tangent squared plus 1, and then another tangent squared.
Yeah.
Where'd you get that about?
What we have right now is secant squared plus tangent squared. Okay? We have secant squared plus tangent squared. But what we know over here is secant squared is equal to tangent squared plus 1. So I'm going to use this and replace it with what it's equal to. Once again, using our substitution principle. We're taking out the secant squared. We're just taking this out right here. The tangent squared is still there. This is still down here. This is still here. And we're taking secant squared out and putting in what secant squared is equal to, which is 1 plus tangent squared. So we are using our substitution principle by taking something out and replacing it with what it's equal to. Take a look at 18. 18 is one of my, once again, ones I like. Number 18. We have 1 over 1 minus sine of r is equal to secant squared of r plus secant r tangent r. Now, I'm going to go through a way of going through the problem and how in my brain it's a little bit easier for me to see. Okay? As we talked about before, there's more than one way to get to Worcester. You go straight down 30, you can go through Orville, you can go through Albuquerque, you can go through Rittman. Still get to Worcester. It may take you a little longer, but you still get there. Extra couple dollars out of your pocket for gasoline. So if we take a look though, we want 1 over 1 minus sine of r equal to secant squared r plus secant r tangent r. What side do we start with? What side should we start with? Should we start with the left-hand side or right-hand side? Why do you say right?
Because there's more stuff.
Yeah, there's more stuff over there on the right-hand side. So let's start with the right. Well, I do have a square term here, but these terms are not squares. So we start running into problems because these terms aren't squares. But this one is. So my first mindset is, since I don't have all squares, let's change the sine and cosine and see where it goes to. So I want you to rewrite everything in terms of sine and cosine. Once again, you should be able to scan down, hopefully, and not sit there and have to flip back and forth the pages. Hopefully you have something that's nice and organized. Bless you. Secant squared r, what can we rewrite as in terms of sine and cosine, Trenton? Okay, 1 over cosine squared of r. Secant squared, 1 over cosine. And secant, we can still do the 1 over cosine. Tangent, in terms of r, in terms of sine and cosine, Kaylee's what? I'm sorry, what?
Tangent of r over 1.
Nah, not tangent r, what? In terms of sine and cosine, tangent's equal to what?
Sine over.
Okay? Sine r over cosine r. Now, once again, as I talked about before, if the problems ask you to add, you add them. If they ask you to multiply, you multiply them. If they ask you to factor, you factor. Might you factor our grades come back. You do what the problem's asking you to do. Well, on the right-hand side here, we have addition and we have multiplication. Well, if we go back to our algebraic mentality, I follow orders of operations. Orders of operations tells us we have to do what first? Right? Multiply first. So let's multiply these first. So I got 1 times sine of r. Then we have cosine r times cosine r. Which gives us what, Chloe? Cosine squared r. Okay, so we multiplied. Now we have to add. We have to add 2 fractions here. Well, to add 2 fractions, we have to have a common denominator. Do we have a common denominator already? Yes, we do. So let's just rewrite this over top of one denominator and see where we're at. So we have 1 plus sine of r. We add the tops. We keep the bottom the same. And we get to a point where we take a look at where we're at and where we're trying to get to. I got a sort of semblance of this on top, but on the bottom I got cosine. I need to get the sine. Well, how can I take my cosine and move it into the sine world? Well, we have cosine squared. So what do we have? What can we take and replace the cosine squared with to move it into the sine world? Minus sine squared. So go ahead and write it in there. If we have 1 plus 7 over 1 minus 7, that gives me 8 on top. That gives me negative 6 on the bottom, which reduced down to negative 4 over 3. Mathematically, since I have addition in here, am I allowed just to do that? Can I just cancel out my 7s? Leaving us with just 1 over 1, which is 1. Can we do it? No. We cannot cancel these things out We can't cancel these things out here when we have addition and subtraction. If we had multiplication in there, yes, we can cancel. But when we have addition and subtraction, we can't cancel. So we can't just cancel out a sign. We had to turn this into the multiplication world. Factoring as a difference of perfect squares. If we have 1 minus sine squared, what would be your two factors if you factor as a difference of perfect squares? I think we actually just wrote them down as we went through this initially. That's why it's important that you have a nice little sheet there, because it will be sitting there for you if you wrote everything down. 1 minus sine squared factors to what? Kind of what's a factor to?
1 minus sine.
Okay, 1 minus cosine, 1 minus sine of r, 1 plus sine of r. Now we take a look. Now we have multiplication. Now we can cancel factors. Once again, going back just to algebra. If you had x plus 3 over x plus 3 times x minus 1. Since I have multiplication here, I can cancel these out, making 1 and 1 to give us 1 over x minus 1. Well, if I take a look here, I now have common factors. 1 plus sine of r. This will cancel with this, with 1 and 1, leaving us with 1 over 1 minus sine of r. We is done. Oh, that's just so much easier in class. Take a look at one last one. Number 27. Once again, another fan favorite of mine. Hint, hint, nudge, nudge, say no mo. Once again, fan favorite of mine. Why is the favorite? Why do I like this? Because it makes us once again go back and review a lot of algebraic topics. And believe it or not, as we go through this one, it's probably easier than some of the other ones. Less work, I'm sorry. If we make some comparison, once again, look to see where you're at, what you're trying to get to. On top here, I have cosines and cosines. I'm going to the cosine world. On the bottom, I have sine, and I need to get that into the cosine world. Well, I have a sine squared. So, rewrite the fraction and take out of the sine squared world and move it into the cosine world. Sine squared, moving down to the cosine squared. Dallas, what do you have? Sine squared is equal to what?
1 over cosine squared.
Not 1 over cosine squared. Sine squared is equal to, look at the right hand side, what we have in our notes. Sine squared is equal to.
Oh, tangent squared plus 1.
Yeah, that's sine, that's secant. I'm looking at sine squared. Look at the very top. Very top. We went through sine squared plus cosine squared is equal to 1. Then one line down from that is what? Sine squared is equal to. Or 2 lines down.
Oh, I got that wrote it down.
It's 1 minus cosine squared.
1 minus cosine squared of x. Okay, need to get that down. Okay, so now we've moved it out of the sine world into the cosine world. Let's go back algebraically. Once again, this allows you to take a lot of the letters out of it and simplify things a little bit more in your brain. You have 1 minus 3y minus 4y squared. I just replaced the cosine of x with a y. Cosine squared x with a y squared. I want you to factor down 1 minus 3y minus 4y squared. I want you to factor that down. Check your factoring with somebody around you. And then translate it down into the problem where rather than dealing with y, you're dealing with cosine. Basically, you take the y out and you replace it with cosine. 1 minus 3y minus 4y squared. Undo your FOIL. What do you have to multiply together to get what? The 1. Is your first multiplication. What times what is 1? Okay? Your 4y squared. What do I multiply to get the negative 4y squared there? And my middle multiplication has to come up with a negative 3y. Which has, once again, absolutely nothing to do with trigonometry. Has absolutely everything to do with algebraic skills.
Knew I should have paid attention a little bit more when we were factoring.
Once again, just undoing FOIL. What I multiply to get the 1 here? What I get to negative 4y squared. And then I have to check my middle multiplication to get me my negative 3 in there.
It's like what?
What's your last terms on each one of these? How do I finish out my factor? What's your last term, McLean? Did you get negative 4y? What can I multiply together to get negative 4y? Negative 2y and plus 2y. But if I do that, just check my middle multiplication. I get negative 2y. I get a positive 2y. Do I get negative 3y? No. So what other numbers can we multiply together to get 4? I went to negative 1. So we have a negative 1y and a plus 4y. Okay, we check our middle multiplication. I get a negative 4y squared. I'm good there. But I get a positive 4y and a negative 1y. Do I get negative 3? Positive 4 and negative 1?
No.
So what do I have to do with my signs? Okay, you got to flip the signs. So we have a plus here and a minus there. So now I can take my y's out and replace with cosine. So rewrite this, take your y's out, and throw in your cosines. Rather than have 1 plus y and 1 minus 4y, take the y out and just replace it with cosine and write it as your factors. One minus cosine squared. Just like we did 1 minus sine squared, 1 plus sine, 1 minus sine. Your difference of perfect squares. Factor your 1 minus cosine squared. That's the difference of perfect squares. Once again, all we're doing is 1 minus y squared, 1 plus y, 1 minus y. Okay, but replace it with y, or the cosines. Do we have any common factors? Top and bottom, do we have common factors? Yeah, the 1 plus cosines, they go bye-bye. Leaving us with minus cosine, 4 cosine over 1 minus cosine, what we're trying to get to, we is done. Once again, really, really, really leans on your algebraic skills of factoring. That's why I like this type of problem. Okay, we're going to spend one more day on this, page 116, 117, 258, and so on. My suggestion, once again, if you want to continue to get better at these, the problems that we did here in class, redo them. Redo them. If you have extra time, redo them. You're sitting in our class that may not have class today because we lost half our kids here, or a quarter of our kids. Okay, redo the problem. And that's the way of how you get better at what we're doing. All right, questions? QED, as done.